Okay, good morning, everyone. So, I'm Paul President of the Director of Graduate Programs here in UCE. And what I'm going to be doing today is to talk to you about grad school. We want to trap you here for several more years. So, there's no exam, they'll be just taking attendance. So what I've got here is actually two presentations. And then you'll hear a short presentation on one specific program here, the Power Systems program. So my two presentations are, the first one is just generally why do grad school? What's involved, what is a master's degree, what is a PhD degree, what are the advantages and downsides of doing those degrees. And the second presentation is why do it here, specifically telling you a little bit about what our programs are about and what's involved in getting in on them. Anytime I'm happy to answer questions. I'll also be happy to answer questions at the end, and I'll stay after class if you've got questions you want to ask privately. But of course, the main reason people want to come to grad school is to work on cutting-edge technologies. And frankly, with a master's or PhD, you are much more likely to be working on cutting-edge technologies than with a bachelor's degree. My personal area is chip design, silicon chip design, so I put that first, of course. But we have a joke in chip design, and that is that bachelor's graduates get to test them, masters get to design them, and PhDs get to architect. And that is actually largely true. A lot of these technologies are only accessible through a graduate degree. But of course, there's a lot of areas that are hot right now, not just chip design. Autonomous vehicles, machine learning, of course, is very hot. Wearable electronics and Internet of Things. The smart grid, which you'll hear about from the EPSI program, including wide bandgap circuits. Other areas that are boiling right now include next generation computing. Computing has always been a large subset of this industry. Communications and networking, particularly security and software-defined networking. Military security and aerospace, building these new types of systems is a big employer in the United States. Bioelectronics is an area that's expanding fast, though still relatively small. And of course, underlying all this, there are people who work on the enabling technologies, such as nanotechnology, packaging, and others, and photonics. So I went through that fairly quickly because this is not a technical talk, but the point is these are all subject areas that are covered in this department in the graduate school, and these are meant to be indicative of the sorts of things that are more accessible with a graduate degree than with an undergraduate degree. And by the way, electrical and computer engineering and computer science also are fairly unique in that aspect of having career paths that are design intensive that benefit from a graduate degree. This is much less so in civil engineering or mechanical and aerospace. So, because it opens up these opportunities, most of these actually have some level of graduate training. This is taken from a trade magazine, EE Design. As you can see here, the right-hand three bars add up to almost 2/3 of electrical engineers. That is, roughly 2/3 of electrical engineers have at least attended some graduate school, possibly just a certificate for some graduate studies. That's 3 classes. As you can see, a master's degree is very common, roughly 1/3. This is a very high ratio compared with other fields. Roughly 1/3 of electrical engineers and computer engineers have a master's degree, whereas 10% have a doctoral degree, and you'll probably pick up the reasons why as I go through them. So this is a very common career path for various reasons that I'm going to go through. First, it's worth talking a little bit about what a master's degree is. Now, you're facing the getting towards the more than halfway through your undergraduate. And so far, you probably noticed you've mainly taken relatively basic courses that are just starting you on the first steps of understanding electrical engineering and or computer engineering in a broader context. you'll start taking advanced classes. As a senior, you'll take a small number of advanced classes. While a graduate degree is 10 more advanced classes. So in fact, in a graduate degree, you'll actually do more engineering, more electrical or computer engineering than you probably did as an undergraduate because of our breadth requirements in the undergraduate. So it's a intense study that gives you specialised knowledge well beyond that a bachelor's graduate would have. During a master's, you can, if you want to, participate in a research project or an advanced development project. And you do that by electing to do a thesis that's equivalent to 6 credit hours worth of work. It's 10 courses, and the standard load in graduate school is 3 courses a semester. So it generally takes 18 months full-time or 4 to 5 years part-time. And so, thank you. Yeah, things great. Thank you. But of course, if you do the accelerated bachelor's master's, it only takes you an additional 12 months on top of your 4 years that you're already doing as a bachelor's student. And we do that by essentially double counting some of the master's courses as being equivalent to undergraduate courses. PhD is very different again. There actually is a requirement that a PhD does original work, that contributes to the knowledge of humanity, expands the knowledge of humanity in a way that no one else has done before. And so there's a very strong innovative / inventive aspect to a PhD, particularly in engineering. That aspect of the degree generally takes about 3 to 4 years beyond the coursework requirement for the master's. A PhD here at least is basically the equivalent of a master's, even if you don't actually get one along the way, but most people do, plus that 3 to 4 years of research. Being research, that part of the degree is actually more like working in a job, a largely self-directed job, in a job rather than study. You don't have weekly assignments as a PhD student. You do work, you give regular updates, you get feedback on those updates, you do other things along the way, and I'll talk about those in a moment. You generally get paid to do a PhD. You are typically either a fellow to support at the university level, or a teaching assistant or a research assistant as a PhD student. And the reason for that is the work that you're doing is valuable to humanity as a whole and to the country as a whole. So it's very important that PhD students get supported in doing so. So that's a little about what the degrees are. Let's talk about why do them. And here I list a summary. I'll go through some of these in a little more detail. Increased earning power is definitely there. If you get at least a master's degree, you'll probably add at least $1 million to your lifetime earnings. And I'll give some annualized numbers in a moment. Faster and further career development. If you want titles like fellow or even chief technology officer, if you want a technical career track where you climb the ladder, then a master's or a bachelor graduate degree gets you on that rung and gets you going better initially than a bachelor's degree. Becoming more self-directed. We have all experienced bad bosses. You might be lucky not to have had one by now, but you probably will have one. The higher the advanced degree you do, the less your boss understands what you do. And the more opportunities you get to be allowed to be self-directed. And you see this in a lot of companies. For example, Google famously allows all its engineers to spend 20% of their time on anything they want. That is a self-directed aspect. Some people also use a graduate degree coupled with other advanced degrees, for example in law or an MBA, to go in a different route. For example, patent law, which is an area of law that's still a quite strong employer, is often a combination of a graduate degree in engineering or sciences and a JD. A lot of MBAs have also a master's degree in engineering if they work in the technology field. Of course, for some jobs, it actually is a job requirement. For my job, it actually is a job requirement. I need to have earned a PhD. That just means I didn't get one as an honorary one. So there's a requirement for faculty to have a PhD. At this point in my career, when I was at your age, I did not want to be faculty. I ended up at that route. You haven't shared that with anyone, but it wasn't my intention at the time. But actually, it's a pretty good gig. So if you want to be faculty, you need to do a PhD. There are many R&D laboratories around the place that will only recruit PhDs. The national labs, for example, Sandia National Labs or Air Force Labs or a place like that. And of course, a lot of labs in private companies expect most of the people there to have PhDs. There's intangible benefits as well. The job can frankly just be more interesting. You get to do more variety of things. You're not expected to be an expert in only one thing and get to do that over and over again. And as I started out with, you're more likely to end up working in newer cutting-edge technologies. And especially with a PhD, but often even with a master's, you are expected, or at least given the opportunity to play a leadership role in the company. That is, formulate what the next products look like, or in a research lab, formulate the new research directions for the lab or even for the country. A lot of faculty in particular work on national boards of various forms to formulate the research agenda for the company, as do a lot of corporate people. Some people do an advanced degree simply because they want to. They want to achieve the pinnacle of technical education and want to do a PhD. Their parents might have PhDs and they might feel undervalued in their family if they don't get enough, they don't get one themselves. Frankly, to particularly do a PhD, you need a strong element of being self-motivated and self-driven, and sometimes that comes from simply wanting to do it and wanting to achieve that goal. And of course, given the independence you get even as a master's student, you're preparing yourself for a better career of lifetime learning. I'm sure you appreciate that you have to learn new things over and over again during your career. The subjects that I even teach here at NC State, the content matter did not exist when I was a student. So I had to learn those myself through various forms. Okay, let's look at some of these in a little more detail. This is, again, taken from EE Design. They do an annual salary survey. I have more recent surveys, but the 2014 data was split out like this, which is quite useful. This breaks it down by degree. Of course, it's gone up a bit since then. But this is industry-wide. So this is showing basis and total compensation for different levels. As you can see, there's in this particular average, there's a 15% jump to a master's and another 10% or so jump to a PhD. In the 2015 survey, they didn't show that data, but they did show this. This breaks it down by area. So this gives the average salary by industry. And for example, semiconductors are 144,000, down to contract design around 100K. Now, I bring this up in a graduate context because this actually largely reflects the way that different areas in this industry employ people with advanced degrees. By far, the majority of people working in semiconductors and integrated circuits have at least a master's degree. In contrast, a lot of people working in contract design, for example, probably just have a bachelor's degree and maybe a professional engineering qualification. So I'm not standing here saying choose a particular subsection of the industry because it pays better. I'm saying the pay in those subsection of industries is somewhat correlated to how much preparation someone has to do to work in that particular subsection of that industry, of our industry as a whole. Turning to career progression, the highest technical ranks in most companies are fellows, and some companies are senior fellows. A fellow is meant to be a equivalent to a vice president in the company in terms of compensation and perks. A senior fellow is meant to be equivalent to a senior vice president. So in a substantial, profitable, high-tech company, fellows tend to earn about $350,000 to $450,000 a year. This is the breakdown by degree for fellows and senior fellows in Inter. They publish their papers. They give the biographies of all their fellows and senior fellows. So there's some in the DTP office actually hide this. As you can see, by far the majority have a graduate degree, and more than half are PhDs. And frankly, most of the bachelor's fellows here were probably with the company when it was formed. And that's how they got to be a fellow by the contributions actually done quite a lot. Now, I've asked my own graduates, why is this? Why do PhDs tend to zoom up the technical track faster than other degree holders? And I said the reason is because of that leadership aspect I brought up earlier. Company recruits a PhD, they just don't want them to be doing the job of master's grade. They want them, if they're suited, to play a leadership role or to be more specialised. Thus, they tend to get more opportunities to contribute to the company. And if some of those opportunities pay out well, they get to shoot up the technical ranks. Generally, in companies, your ability to reach the high technical ranks is proportional to your financial impact on the company. So because there's more opportunities to do the sorts of projects that allow you to climb the technical ranks, it tends to be that more advanced degree holders get to climb the technical ranks. Below fellow and senior fellow, there's titles like this, technical director, architect, senior principal engineer, consulting engineers. This is typically the next rank or couple of ranks down. A technical director in a company, in a high-tech company, is meant to get the same pay and perks as a director. A total package typically, say, around 300. This varies a lot. And again, they're disproportionately populated by people with advanced degrees. Architect gets to define products and what they are going to look like in the future. Again, disproportionately populated by people with advanced degrees. Not necessarily PhDs at this point. A lot of people at these ranks will have masters and, of course, many years of experience. So, in terms of this part of my talk, the general introduction to graduate degrees, these are the resources you can turn to if you want to verify this stuff yourself. So I talked about e-design, electronic design salary survey is available, it's openly accessible on the web, you don't have to be a subscriber to the magazine. And they have a salary calculator. In fact, it's probably worth your while when you graduate, start getting offers, to go to the salary calculator and see how competitive the offers are, because they're based on survey data in your region. The IEEE careers site also has a lot of information and a more detailed salary calculator that you'll find in electronic design. The only thing with the IEEE salary calculator, if you take their salary survey, you're allowed to do 5 calculations for free. If you don't take their salary survey, you have to pay to do a certain number of lookups on their salary calculator. Still probably worth it to help you negotiate your package once you get going. It's rather high level, but the Bureau of Labour Statistics does collect data on different career tracks. the number of people working those tracks, the expected growth in those areas, and so forth. And IEEE Spectrum also has articles on tech jobs and further information about the profession. So that's the first part of my talk. Why do a graduate degree? And I just sort of pause at this point to see if you have any questions that I can answer. Yes, please. Okay. So the question is, what's the relative value of being a licensed professional engineer versus having a master's degree? Now, as you know, to become a licensed professional engineer, as you mentioned, you need a certain amount of experience. In addition, you have to pass the two sets of examinations. The second set of examinations are actually quite hard. The value of a professional engineer is they can sign documents. I'm not trying to belittle it. They've earned a right to legally have authority over projects. But generally, that's the main thing they're adding to a company. They can sign plans and other documents. So if you're working in construction, for example, or consulting to a construction company, they want electrical engineers or professional engineers to sign documents. Presumably there's a paid bump with that because you're also taking risk in signing those documents because you're putting your name on the line when you sign the document. But that's what that's in a nutshell is what a PE adds to it. Most people who design products in large companies are not PEs because they don't have to sign documents representing the legal structure. They're doing design of a product. So they're actually quite separate career paths. If you're going into project management and things like that, a PE can be quite useful and remunerative. If you're going to be a design engineer and do product engineering, then there's generally not a lot of value in having a PE. Any other questions at this point? So let me talk a little bit about what we have at NCSU in terms of grad programs. So we have actually technically 8 master's programs and 2 PhD programs. The master's programs, the core programs are computer engineering and electrical engineering. We also have a computer networking program and electrical power systems engineering program that you hear about later. In addition, we have online versions of all 4 of these programs. So hence that makes 8. PhD is simpler. We have computer engineering and electrical engineering. Power systems would be in electrical engineering. Networking can actually be in either, depending on the details of what you do. Just like as an undergraduate, if you're choosing between computer engineering and electrical engineering, it's really a function of the courses you choose to take. If you take more computing courses, you'll probably better fit our computer engineering degree versus the alternatives. A master's requirement is basically 10 courses beyond the bachelor's, though you can count a 400 level course from another department, or it can be 8 courses plus a master's thesis. And these courses are, though they're roughly equivalent to your courses you'll be taking as a senior, they do tend to be a little more involved and, of course, more advanced. One thing to, of course, realise once you're in the master's program, the weaker half or more of the class is gone. So we're left with the stronger students, and they're pushed harder than you probably would be as an undergraduate. Our PhD requirements, we restructured these just last year. It's basically a master's, whether you actually get one or not, plus the research component. So if you direct enter as a PhD, you take 10 courses and you satisfy the coursework requirements for a PhD. If you have a master's from here, or if you're not from here, obviously you'll be from here, but if a student isn't from here, then we'll often count a master's from another university as being equivalent. Another US university generally. And officially, there's various exams through the PhD process, but it's largely a function of the research that you do. Those 3 exams are a qualifying review, which is set by a group. It basically says you're ready to do a PhD, and the criteria show it changes by the group. There's a preliminary examination, which is actually a thesis proposal. This is what I want to do. I want feedback. And there's a final thesis defense, and of course you write a dissertation with that as well. The routes into these programs are summarised on this slide. And of course, this is largely aimed at you. As you're probably aware, we have the accelerated bachelor's masters. This is very deliberately done to give you a master's degree in 5 years from entry, rather than 5.5 years if you don't do the accelerated program. Does need a good undergraduate GPA for Townsend to approve it. We have quite a number of your peers, your predecessors in this program. If you want to do a master's and have the requirements, it's really a no-brainer. Of course, you can graduate with a bachelor's and do a entry as a conventional master's degree, add on 18 months. You apply and you get accepted or not. We generally don't. Most schools require at least to some degree what's called a graduate record examination. This is kind of like the SAT, but for potential graduate students. And we don't require that for our own graduates, or actually graduates from other US universities with meet certain GPA requirements. That's kind of nice because it's a big exam to prepare for. Some students who might not meet the GPA requirements, generally looking for a 3.0 for master's entry, will try out the master's degree by taking non-degree studies. They then get to count those courses to their master's degree if accepted. So a number of students will take a course or 2 with non-degree studies, get A's and B's in those courses, and you'll probably be admitted to the master's program. So some students are a little unsure if they want to do it, or a little unsure if they get admitted might do that. For students from here, there's 2 routes to the PhD. One is to apply directly from a bachelor's and get admitted. You can also, of course, apply from a master's and get admitted. If you in the PhD program, even as a PhD student, you can get what's called a master's en route. That is, at some point you say, "Hey, I've met the requirements for a master's. Can I have one?" And they say, "Sure, here's one." And that's frankly what it is. And a lot of people do that. If you enter as a master's student, then you can convert to a PhD. While you're a master's student, you have to still be a master's student. That's fairly simple. You find an advisor and another faculty member to say on the form that they want you to be a PhD student, and 1 semester later, you're a PhD student. Now, if you want to do a PhD, if you know that from your bachelor's degree, the best route is direct entry into the PhD program. And the reasons for that are fairly simple. You'll start working with faculty on your potential research project, even if it's just learning the ropes type of thing, straight away. In addition, there's a lot more financial packages available for, yes, I know about that. A lot more financial packages available for PhD students than for master's students. How do you choose a master's program? A number of you will consider programs at other universities as well as here. I'm going to talk about factors that come into play, and of course talk a little bit about here. For a master's degree student, probably the 2 most important things are the course offerings and who recruits there. You want a large, substantial program that has a rich set of deep technical courses. And part of our reason for that is such programs attract all the national companies to recruit. For a master's degree, these 2 are probably the most important factors. You might also consider school location. Do you want to live there? Do you have local employment opportunities? A lot of our master's students who graduated from NC State work at least part-time locally. As you know, there's lots of employers around here, and it's relatively easy to get jobs with them, even part-time while you're a student. And of course, if you're interested in staying there afterwards, that enters into it as well. Some people settle down a bit while they're a graduate student. There are rankings out there. My advice is to take them with a bit of a pinch of salt. There's the famous US News and World Report ranking, and it's for individual programs. It's 100% a survey. I've done these surveys. Even though I'm not a department head, I get a piece of paper. Well, I get an email now, a screen. Rank these 100 programs, and I go, if straight from there is good, that must be a good place. I don't know on there, must be a bad place. Frankly, I can't research 100 schools and make an objective ranking. I do it very subjective, and most people do. So there's a lot of the US News and World Report is not very accurate at this level. I'd suggest you might want to look at bestengineeringcolleges.com because they claim to be data driven. Furthermore, they don't publish the algorithm so that schools can't game it. Schools game US News and World Report all the time. You might consider the investment required, on the tuition and fees and other costs. One question I often get in this sort of session is, should I switch school for a master's and or for a PhD? Now, if you're a science or arts student, the answer is often yes. And the reason is different schools have different philosophies. Give an example. Chicago School of Economics is quite famous for being quite conservative and don't believe in Keynesian economics, that is stimulus. Harvard or MIT, on the other hand, are quite liberal and do believe in Keynesian economics. So you get quite different exposures to those different schools, and often it's worth getting different degrees at two different schools like that. In engineering, have you everyone talked about the philosophy of engineering and how Stanford might be different than MIT in its philosophy designing a circuit? No, it's much more objectified. We teach basically the same approaches to everything. So you don't need that different thinking that comes with different schools in engineering as much as you do in the sciences. So in the sciences and the arts, it makes sense. In engineering, my observation is it doesn't make a lot of difference. If you're interested in knowing more about our master's program, our graduate portal on our main website has a lot of information, including courses. And of course, if you want to know more about what companies recruit here, you can go to the career fair site here. I know you can't read this. This is very deliberate. This is a list of all the courses we taught at the graduate level in fall 2016. And this is a list of all the courses we taught at the graduate level in spring 2016. I'm just showing you the richness and breadth of our program. And this is a list of all the companies that were recruiting computer engineers at last year's career show. There were over 100 of them. So, as I said, you want to go to school. Now I'm selling our school. You want to go to a school that has a rich set of courses and a rich set of companies that recruit at the school. These actual statistics, a lot of these companies overlap. We didn't have 300 companies at the career fair. I would typically get about 120 total. Obviously, no, about 140, 150 total. But you can see that a lot of them are recruiting our graduates. And this is the ranking data from bestengineeringcolleges.com, which we do relatively well in. Another common question I get is, should I do it full-time or part-time? Should I delay it? Which I didn't put on the slide. My advice is, if you can, continue, roll on, knock it out the way full-time. Then it's done, and you can get on with life. And enjoy that big earnings bump that comes from having the degree. This is both for the Masters and the PhD. Part-time, and for Masters, it's 3 to 5 years. there is an advantage to working full-time, and you've got an employer who's probably paying the tuition costs. Those are very nice things to have. But it's a drag, right? You're spending nights and weekends studying for 3 to 5 years. Part-time PhD almost doesn't exist. Very few students achieve doing a part-time PhD. You really have to be full-time for a PhD. We also have a very strong online program, so you don't have to physically attend classes and can work remotely. We've even had military students in Saudi Arabia and places like that taking the online program. This again is 3 to 5 years, obviously, because it's part-time. But it doesn't have to be full-time, but usually is, and it's usually employer-supported. You don't have to physically attend. That's a plus and a minus. It means you also don't develop the study network that can help you through various things. PhD program, factors in choosing a PhD program. The number one, most important factor by far is the advisor. I'll talk about this more on the next slide. The advisor sets the topic, sets you up for your career. Is probably more and is either well known or is not well known. It's probably and can open doors for you if he's well known. This is more important than actually the school or the school ranking. Of course, you still have to take some courses, so the course offerings are important. This is a disadvantage of a small school. Location may or may not matter to you. Are you headed to faculty or to industry? Some schools tend to disproportionately send people to industry. Frankly, that includes us. Some schools tend to disproportionately send students to faculty. It's important to talk to current students at the school, particularly current students of the advisor you want to work with. Of course, companies recruiting there matter. Rankings do matter to some degree. Obviously, a degree from Stanford has extra value, for example, over other degrees. It's also much tougher to get into and to get, of course. The package offered, as I said, most PhD students are supported during their career, so a lot of students look to the package to see what it looks like. And you also want to get a general feel, particularly if you visit a university, as to the general level of research resources. Is there one laboratory with one oscilloscope in it, or is the school well equipped? But I really want to hammer on the importance of the advisor. The national prominence of your advisor is a big impact on your career. If he or she is prominent, it'll attract employers, it'll open doors, they'll otherwise be closed to you. You'll also be working closely with this person for several years. So you do want to know what the style is of the advisor and whether it suits you. Do you want to be closely managed? Then find someone who closely manages. If you don't like that, then find someone who doesn't do that. Get a feel for how the person treats his or her students. Now really, the only way to do this is to take advantage of visit programs that schools do offer potential PhD students and talk to the students of the advisor. As DGP, students sometimes ask me about particular advisors. I've got to be a little careful with my colleagues. But I will affirm if I know someone is good. I won't say if I know someone is bad. Of course, we have information on our website about programs here. Given the importance of the advisor, you do want to look at the faculty websites, mainly to see initially if the technical interest, and that's yours. And you can find about the advisor's funding levels by looking at our projects page. In addition, here we have a number of programs that help prepare PhD graduates beyond just the technical aspect. Grad School runs some programs, the college runs some programs, and the department has some things as well. And here I've listed what the Grad School does. As I mentioned, most PhD students are paid to do their research. There are generally four types of support. There are national fellowships that are available. For example, NSF, Department of Defense, Semiconductor Research Corporation. These are very competitive. They are very generous as well. It can be quite useful to get a first author publication to have better chance of getting these. How do you get a first author publication? Do a research experience as undergraduates project. You get paid $5,000 or $6,000 to work with a faculty member over summer. We have a number of university fellowships that students are selected for during our recruiting. And of course, we have teaching and research assistants. Teaching assistants are supported by the department. We've already met a number of them. Research assistants are supported usually by the contracts and grants of the faculty member, though there are some RAs supported by the university. So that brings me to the end. I went relatively fast to leave some time for questions and for FC. Sum it up, the master's degree, if you actually like this stuff and are somewhat good at it, a master's degree is a no-brainer. It greatly increases your lifetime earnings and career satisfaction. PhD is a little different. It's a big investment. It still pays off. You still earn more over your lifetime, but it takes a while to catch up because you spend those extra years at university. And if you're good at this stuff, it can be very rewarding because you get to shine quickly in your circumstances for a PhD that are not accessible to a master's. So that's all I plan to cover. Does this finish at 1 or 1:10? I was told 1:10. 1. So what I'll do is I'll switch straight over to Teresa's going to talk about the FC program. I'll be staying back for questions. I'll be happy to answer any questions. Are there any quick questions now? Okay, thanks very much. I'll turn it over to Teresa.